Hey, today we're going to be taking a look at our next lesson. This unit's going to be over polynomials. Now, a polynomial is a very special type of equation. We do have some experience working with it, where a polynomial function is typically going to be something like a quadratic that we've worked with, even a linear. It could go up to an x cubed, it could go up to an x to the fourth, so on and so forth. What it is it's an equation where the definition you can see up on the screen, it has whole number exponents, and that's really the only catch on it. The other thing is the numbers in front of x have to be real numbers. We cannot have an imaginary number sitting in front of x. So what we're going to look at with that is we're going to look at just a couple of basic vocabulary terms in regards to a polynomial. So we have a polynomial example up on the screen. 7x to the fifth plus 2x cubed plus 6x minus 3. The first thing about this is we would say this equation has what we call 4 terms. Okay, one for each part of the equation. The second thing is what we would call the degree. The degree is the largest exponent that's present in the equation. Because of the way the polynomial is defined, we typically want to put the largest exponent at the front, and because the degree is such a large important thing that we'll typically look at what we call the leading coefficient. Now, the leading coefficient is not necessarily in the front of the equation. It's in front of the degree term. So if the 7x to the fifth was somehow at the very back of the equation, 7 would still be the leading coefficient because it's a degree 5 polynomial. It is with the x to the fifth. The other thing is the negative 3 at the very back right now. The minus 3, you can see, has no x, which is different from all the rest of the terms in the equation. This is why we call it a constant, because no matter what x is, it's always going to end the equation with minus 3. And that's a constant that will never change. Now, we need to be able to do 3 basic operations with the polynomial. The first 2 are that we need to be able to add and subtract. Now, with adding and subtracting, they are typically set up fairly easy, and the whole process could be summarized the same as the process with imaginary numbers. We're going to combine like terms. The way we tell something is like terms, it has the same variables, it has the same exponents, and then we'll add or subtract the terms as written. So, we've got 2 examples on the slide, and each one has a total of 2 different polynomials. So the first example, we have 3x cubed plus 2x squared minus 5x plus 7. And we're adding a second polynomial of 4x squared plus 2x subtract 3. So what we're going to do is we're going to just kind of start by looking at a little bit of information here. So you can see I just kind of wrote it out without any parentheses now. So I'm just taking the 2 polynomials and I'm putting them together. And then I'm going to start looking for like terms. I'm going to start with the largest exponent and go down from there. So my largest exponent in this problem is 3x is 3. So this is a degree 3 when we combine it. And our leading term will be 3x cubed. And then I'm going to look for squareds. So I see 2x squared, 4x squared. 2x squared plus 4x squared would make 6x squared. The next term, I would look for my 2 linear terms, negative 5x plus 2x, which in case negative 5 plus 2 would be negative 3. Then we would look at our constants. 7 minus 3 would be 4. And that's all there is to this. Now, when we get to subtraction's a little bit different. Subtraction, we have to take the negative sign, we have to distribute it into the parentheses that immediately follows it. After we do that, it's going to be exactly like number 1. So what we're going to do is we're going to take the negative and distribute it to the 5x squared, negative 4x, and positive 6. So you can see the first parentheses, the first polynomial doesn't change at all. The signs are still exactly the same. However, when we look at the second polynomial, now we have negative 5x squared we have positive 4x, and we have negative 6. When we start to combine like terms, again, just like the first question, I only have 1 cubic. So I start my answer with 2x cubed. The second is that I see 8x squared minus 5x squared. When I combine those two, we have 3x squared. Next thing I would look at is my plain x's. In this case, I see positive x, I see positive 4x. 1x plus 4x would be 5x's. And then finally, we would finish with 10 subtract 6. 10 minus 6 would be 4, which was going to tell us our answer, if it'll let me see it. Okay. So that would be considered our answer. Combine all our like terms, and that would be it. What I would like for you to do is I would like for you to go ahead and just kind of take a look at the next question. Okay, on these next set of questions, try working with a partner. And what I would like for you to do is I'd like for you to pause the video, just kind of work out the problems for the next 5 or so minutes. When you're ready, go ahead and push play again. Okay, the answers are as follows. So you can take a look at the answers to 1, 2, and 3. If you're having trouble, please talk with a neighbor, talk with somebody around you who is understanding. Make sure you understand what's going on. The next big term that we need, or the next big process we need to make sure we know, is multiplying. Now with multiplying, just like with complex numbers, I'm going to use a Punnett square to kind of help me organize my process on this. So for example 1, I've got x plus 3 times 4x squared plus 6x plus 7. So I can see that my first polynomial has 2 terms, x and 3. When I look at my second polynomial, I see 3 terms, 4x squared, 6x, and 7. So I'm going to set up a 2 by 3 Punnett square. On the left side, I'm going to use x and 3. Across the top, I'm going to use 4x squared, 6x, and 7. Now, just a reminder, when you're multiplying with polynomials, we will kind of add the exponents. So if we had x squared times x, that would be 2x's plus 1 more, would give us a total of 3x's. If I was doing x squared times x squared, that would be 2x's times 2 more x's would give us a total of 4x's. X cubed times x squared, so 3x's times another 2 would give us a grand total of 5. So you should be able to combine exponents like that. Now when I actually go to multiply this, in the top left we have 4x squared times x, which would give us 4x cubed. In the bottom left we have 4x squared times 3 would give us 12x squared. Top middle we have 6x times x would give us 6x squared. The bottom middle we have 6x times 3 would give us 18x. In the top right, 7 times x would just be plain old 7x. And then we have 3 times 7 would give us 21. Now when we go to work this, we can see, well look, we've only got 1x cubed. I can see 2x squared, so I see 12x squared and 6x squared. I see 18x and 7x, and then I see a regular 21. So when I start to group my like terms, I would use that information accordingly. So 4x cubed, and then we have 12x squared plus 6x squared would make 18x squared. When I have 18x and 7x, that would give us a total of 25x, and then we just have a 21 left over at the end. Okay, so taking a look at another example of multiplying polynomials. Our next problem, we have x plus 5 times x squared plus 4x minus 5. Just like the last problem, I have 2 terms in the left parentheses with x and 5, and we have 3 terms in the right polynomial of x squared, 4x, and negative 5. So I'm going to set up another 2 by 3 Punnett square, where I have x and 5, and then across the top, x squared plus 4x minus 5. Start multiplying. In the top left, x squared times x would be a total of 3x's, so we'd write that as x cubed. In the bottom left, we have 5 times x squared would be 5x squared. The top middle, we have x times 4x would be 4x squared. In the bottom middle, we have 4x times 5 would be 20x. The top right, we have x times negative 5 would be negative 5x. And in the bottom right, we'd have negative 25. So this time I am going to actually write the whole thing out, where we have x cubed plus 5x squared plus 4x squared plus 20x minus 5x minus 25. When I group my like terms together, I have x cubed, 5x squared plus 4x squared would be 9x squared. We have 20x minus 5x would be 15x, and then we have minus 25 at the end. Okay, so what I'd like for you to do is I would like for you to take a look at the next couple of problems. I would like for you to go ahead and try them. I would like for you to pause the video, try the problem. When you're ready, go ahead and push play, and then take a look at the next one. Okay, so that's a first example for the you try. Now what I'd like for you to do is, again, pause it, try the next problem, don't push play again until you are ready to actually see the problem worked out. This time I did end up with a 3 by 3 Punnett square because we had 3 terms in the left polynomial and 3 terms in the right. So it did give us a lot more like terms when we did it. Okay, it gives us the final answer of x to the 4th plus 2x cubed minus 2x squared plus 7x minus 2. Okay, so again, pause the video, try this next problem. When you're ready, push play, check your work, at which point you should be ready for the assignment. Now, the assignment over adding, subtracting is due before you leave today. The assignment over multiplying is due immediately upon arrival to class next time. The final thing is you will have a quiz over adding, subtracting, and multiplying the next time we come to class. So please make sure you take this seriously. No late work will be accepted on this assignment. Okay. The final answer would be x to the 5th plus 3x cubed minus 4x. If you have a problem with anything, you need to email me today before your class period is over. Again, you should be able to just message me on Google Classroom. It should be very easy to do, and I will get back to you. I will have my iPad with me all day. Have a great weekend, and I'll see you all next week.